Okay, we are live now.
So, Assalamu alaikum, everybody. Welcome to yet another international webinar organized by Platform for Research and Development, PRD. I am Tasmeem Chaudhary Boni, Assistant Professor at the Department of Economics, East Delta University, and your moderator for today's event. Today, we have organized a very interesting webinar, and the webinar is titled Business Analytics, Concepts and Applications. And we have a very special guest with us today who will be speaking about his expertise, about his experience with all of us. And he is Mr. Imran Salim. He's currently working as a data scientist at Koch Industries, Kansas, USA. He has completed his master's in business analytics and from Oklahoma State University. He has completed his bachelor's of business administration and marketing from University of Dhaka, Bangladesh. He has experiences in developing and deploying end-to-end machine learning models in AWS using AWS SageMaker, ECS, Lambda, Step Functions, and Kinesis. He's an active user of Python, Power BI, AWS, SAS Enterprise Miner, SAS Enterprise Guide, Tableau, JMP Pro, Microsoft Office Suite. He's proficient in predictive modeling, statistical analysis, regression analysis, text mining, and optimization. He also has 3 years of experience in working for a Fortune 500 special financial organization in customer services, policy administration, and change and lean management. Before I move ahead and let our speaker go ahead with his presentation and webinar, I would like to request all of our participants who is joining from across the world, please drop by your suggestions, comments in the YouTube that you're accessing in the live version. We will be taking your questions and queries at the end of the session. So, Mr. Imran Salim, over to you.
Yeah, thank you for the introduction. I will go ahead and start sharing my slide. Is my screen visible?
It is.
Okay. Yeah, thank you very much for the introduction, and good morning, good evening, everyone. It's early morning where I am from. So wherever you are joining from, greetings, and thanks a lot for joining today. So the topic of today's session is business analytics, concepts and applications. I may use business analytics and data science interchangeably, so don't get confused or anything. This is just like another name for data science. Data science is like interchangeable with business analytics, so just a heads up on that. So for today's session, what we are going to discuss is I'll just give a brief introduction of myself, although Bonyapo has already given an introduction. And other than that, we'll define what business analytics is, what are some of the technologies used in business analytics, what are different types of analytics and applications of data science or business analytics. So I think Bonyapo has mentioned almost everything. So what I would just mention in addition to that, that I have been working for almost 3 years at my current role. I work as a data scientist, and the company that I work for, it's a manufacturing company, and I particularly work in the company that produces fertilizer or nitrogen based fertilizer. So I work in analyzing data to solve business problems. So that's just like one line description of what I do. And some other things that I do is just whenever there is a problem in business and they feel like, okay, we want to understand this problem a little bit more, and then in that case we go back and identify what are the data sources available related to that problem, talk to to talk to the people who are involved with the business to understand the business process and connect to uh, try to connect the business to the data. And then we do some analysis on the data to identify, okay, what's the problem, what might be the solution. And it's like more like an iterative process where we are in close contact. And in some other cases we also build some developing or predictive models where we try to predict any future event, like when a particular equipment in a plant is going to fail, or what's the demand going to be in the next week or next month, or what's the price is going to be of a particular product, and so on. So without further ado, I'll move on and define what business analytics is. So I did a similar webinar with another group, and in that session, I asked, "What do you understand by business analytics?" So this is just called word cloud, and in this word cloud, you can see it's just like summarizing whatever the words were in the answers of those students. And you can see data was mostly used word, or most frequently used word, so that's why you see it's the bold one. And you see some other words like skill, and here you see technologies and decision and analyzing. So all of these words actually kind of sums up what business analytics is. And this is just like a simple program in Python to like create such things. So you can just like do some provide some data, and it will give you similar output. To more formally define, business analytics is the collection and analysis of data to make better decisions. Everything comes down to decisions in business analytics. The reason for anyone is doing any analysis or um, any analysis of data is to improve the decision making or make some sort of decision, whether it could be something. Say for example, if you're going to a store, you are a store manager, and then you want to improve, say for example, um, employees. You want to improve when to place more employees, and you see, say for example, at 10 in the morning there is a rush of customers, so you may want to put more employees on the floor. So all the time it will be coming down to making some sort of decisions. And in that process, what we do is taking in and processing historical business data. I'm saying historical business data because whatever data you have collected, or whatever data your organization has collected up to that point, those data are usually saved somewhere, and you use that data for your analysis, which is related to the business problem at hand. And then you do analyze data, try to identify some trends and patterns and root cause. So it's like looking at the data in different ways to see actually what has happened. And using that analysis or understanding, you make some data driven decision. So the flow goes like this: there is data, and data itself doesn't tell you anything because it's just like some numbers and text. uh, to be able to use that data, you need to derive information from that data. So one example would be, okay, you have customer data. One information would be, okay, the customer's average income is $100,000. So that's an information, but it is still not an insight, or you can't yet make any decision. And then when you're going to insights, say for example, you are going to launch like a super luxury car which costs $500,000. But since your customers average or median income is $100,000, that may be, okay, my customers might not buy this product. So you may think that, okay, what price car price range car my customers might buy, and then make decision, okay, instead of going to launch this or build this super expensive car, I will probably develop and build a car and try to sell a car which may be ranging 50 to $100,000. So what type of decision you take, it will actually depend on the business decision that you are trying to make, and it will vary depending on domain expertise, business knowledge. But the prior process, the data and information and insights would be more or less streamlined, but it will also depend on some expertise that you will gain over time when you work in this area, that okay, how to look at this data, what information to derive, what insights I can gain from this. Now, where does all this data come from? So there are two different sources of data. One is called structured data and another one is unstructured data. So structured data would be transaction systems. Transaction systems is like whenever you make a purchase using some automated machine, or when you swipe your card at any point of sales, that's a transaction. So those transactions are saved even if you don't swipe your card, even you make some cash payments. If it's processed into a digital device, those transactions are stored somewhere. That gives you information about what time, date this product was purchased, which products were purchased, what's the number of the inventory, and some similar information. And then there is customer demographic data. So you have, for example, a subscription service where customers subscribe. uh, One example could be like Netflix. So Netflix has millions of customers, so they have other customer information. And demographic data could be something like, okay, your age, your gender, and your income, your location. So those are demographic data, and those are also quite important data to segment customer, to understand customer behavior a little bit more better. And then there is customer survey data. You may proactively do survey on a sample of your customer, and then you may want to analyze those data. But with the advent of like lots of other ways of collecting data, survey data is still important, but you are getting way more data in different other sources. So unless you can get the similar information from that data, you are not going to conduct a survey. You may want to do a survey when you want to know answer of a particular question, that okay, if I launch this product, are you going to buy? Or what's your opinion about this customer that this product that I haven't launched yet? So similarly, uh, you get most of those answers from other sources. Like nowadays, whenever you visit a website, they have some sort of cookies which is actually tracking you across other websites you are visiting, to understand what type of product or what type of services you are looking for, what your interests are. Those are to some sort limited. It may not be able to get specific demographic information, but it may be able to uh, identify one person to like some unique ID, but not maybe to the level of name. And there is Internet of Things. Internet of Things is any device that's connected to internet. Nowadays you will see a refrigerator is being connected to the internet. You will see Amazon Alexa, smart home devices which are connected to the internet. So all these devices and all these things that are connected to the internet are called Internet of Things. And these devices also provides lots of data. And another example is plant equipment or sensor data. This is particularly related to my work. So at the manufacturing plants, there are lots of huge equipments, and huge equipments have different part of assets or different type of smaller equipments. And all these equipments have multiple sensor that collects data about if it's a vibration asset, it will collect, okay, what's the RPM or rotation per minute for this vibration, what's the temperature it is operating at, uh, and similar, lots of similar information. Now, why this is important? Because this is generating huge amount of data that will tell you about the health of the equipment, and it's of paramount important to run a plant as long as you can without any unforeseen shutdown, because that's even more costly. So this type of data are used in predictive maintenance to see or to assess when an asset is going to break down. I need to fix or work on this before it's breaking down. And there is another whole area of unstructured data, and nowadays, maybe I'm not sure about the number, but more than 80 to 90% of the data is generated. The data being generated is unstructured data, which is audio, image, video, and text. These are unstructured data because it's kind of like you cannot store this data in exactly a tabular format. These are stored in different formats. So analysis of this data, this type of data, is a little different than analyzing structured data, because the structured data is in a tabular format. And I'm going to give example of a structured data in the next slide. So this is just like a made up data. And here you can see it's an example of customer demographic data, or customer loan data, you can say. So I have customer ID, gender, age, income, how much loan balance do they have, how long has they been member of my organization, have they ever been defaulted in loan. And here dot means like this three dot means there are lots of other information. Similarly, vertically there are lots of other information. And this is in a table format, and this type of data are usually stored in a database. So this is called tabular data or structured data. And this is example of unextracted data. So I took this screenshot from Google reviews of one of the um, superstore in Bangladesh. Its name is Agora, and you can see it has some structured information like here it's 3 star, right? So if I collect this information in a table, it's going to be a value of 3, and it's going to be a value of 4. But again, there is information, collection of groceries is good, offers and coupons ain't that much satisfactory. So this is a text, but think about this Agora branch has hundreds of locations. I actually don't know if they have hundreds of locations, but for the sake of argument, let's assume they have hundreds of locations, and each location has lots of review. This one has 2,000 reviews. So if someone wants to analyze this data manually, they have to go through those 100 website pages and go through those 2,000 on average reviews each. But using business analytics concepts and practices, you can analyze these texts in a much more digestible and efficient format that would be easier for you to understand customer satisfaction level. You may want to understand, okay, what customers are satisfied about, what customers are not satisfied about, where is my room of improvement. So you would be able to make decisions that will improve your businesses. Now let's discuss about what are different types of business analytics there. So the first one is descriptive analytics. So descriptive analytics is analyzing the historical data, and this is done particularly to understand actually what has happened in the past and identify trends and patterns. And trends and patterns may be, say, for example, you are in ice cream business, and ice cream sales peaks in summer. So that's a trend that okay, in summer ice cream sales increases, and in winter ice cream sales decreases. Sorry, that's a pattern. And trends is similarly if you have an increasing trend of your sales year over year or decreasing pattern. So this tells you what has happened with your business. And example would be like, okay, new customer acquisition, am I increasing or acquiring more customer month over month? Is my sales growth slowing down or it's increasing? uh, Another one, the next one is diagnostic analytics. So in this stage you try to identify what actually has happened. Sorry, you have identified what has happened, and in the next stage you are trying to identify okay, why this has happened. And you may want to try to answer the questions like okay, why my customers are leaving, why sales is declining. And you will probably use more slices and dices to look at data from different angle to answer these questions. One example for the customer, why my customers are leaving, I may try to look it at by different products, look it at by different region. And if I see okay, my customers in the um, South Asia are declining, what might be the reason? So you may want to dig a little bit deeper and try to identify okay, in Bangladesh, in Chittagong customers are declining. Then you may want to identify, talk to more people, try to see okay, actually why customers are leaving. So you'd be able to diagnose or pinpoint where the problem is occurring. And the next step is predictive analytics. So this is uh, by data science, most people refer to this, but actually data science is if you are working any type of work, if you're doing anything with data, that would relate to data science. So predictive analytics is what is going to happen next. So if you have a customer base, you may want to know which customer is going to leave or which customer is likely to leave, because that will give you a valuable information that okay, my this one customer or this group of customers are at higher risk of leaving. What can I do to retain them? If you have taken some business courses, you may already know that acquiring customers is more expensive than retaining existing one. So you may have good incentives to acquire your existing customers from churning. Churning means like when a customer leaves your business. So you may want to give them a discounted price for certain period, or you give them some coupon so that they come back and use your businesses. And this also helps you with your profitability, because you are not offering the same promotion to all the customers, which may be more expensive. You are offering it to a particular group of customers who are high likely to leave or churn, and you have identified that through predictive analytics. And another would be like sales forecasting. You want to forecast how much you are going to make in sales in next month, so that you can better plan your resources and your inventory and your production process. And the next step is prescriptive analytics. So this is taking predictive analytics to the next step. And here you are recommending outcomes. um, Sorry, you are recommending actions to achieve the best outcome. So when I say recommending actions, if I further illustrate that previous example, I am saying that okay, if I offer this group of customers or these 100 customers 20% off in their current pricing, they are higher likely or more likely to be retained. So how did I come up with these numbers? That's kind of like from predictive analytics. I will play with different values like okay, 1%, 2% through 50%, what would increase the portion or percentage of the customer retained. And from that I'll be providing or coming up with value, what percentage of promotion to use. Yeah, so I think I had mentioned that in the next point, that offer promotion to customer John Doe to prevent churn. So in I mean, instead of offering the promotion to all the customers, I'll be providing the offer or promotion to only a small group of customers. So the next slide is just kind of some buzzwords, and just trying to define those buzzwords that you may hear here in some articles or in news or like some text. So artificial intelligence, machine learning, deep learning, all of these could be part of business analytics or data science, but these are some specialized application of business intelligence. At the core or at the bottom is deep learning. So deep learning is just using so deep learning derives from a process that tries to mimic the way human make decision, or human processes information, or human learns. So that's why it's called deep learning, because if you think about human brain, it's connected through neuron, and information is passed through from one neuron to another neuron to another neuron. And when you think about how you recognize something, say for example, recognize an orange as it being orange, it's not like all the whole picture is stored somewhere. There are some neurons which are specialized in connecting the shape. There are some neurons which are specialized in uh, recognizing the color, and so on. So when all of those information are processed in the brain, you connect that, okay, this is orange. So this deep learning is similar concept that's used for mainly object recognition or image recognition, which is also known as computer vision, and text analysis, or if you see any translator, those are used using deep learning, and also used for text analytics. And it also could be used, or it's also used for uh, excuse me, also used for tabular data as well. But for usually for deep learning, you need lots of records to be used it more efficiently. And deep learning is a subset of machine learning. It's just like the algorithms with the ability to learn without being explicitly programmed. So it's just like the capacity of a computer program or computer algorithm that can learn if you give it some example. So the way example could be, or the way you organize data, you can refer back to the tabular data, that okay, this customer joined me 36 months ago, his income is this much, he has this much loan in default, and he has I'm trying to predict whether he's going to default on loan. But I have previous examples of similar customers. Okay, these other customers had similar behaviors, whether they have had defaulted on loans or not. Based on that, the model is trying to learn what will happen to the next customer. So if you think or see that, okay, from past example, the machine is learning. So this is similar to human decision making as well. Say for example, if you are leaving for your work from home or school from home, you know that okay, it's going to rain tomorrow from weather prediction, and you know that okay, if it rains, it's a little difficult to navigate throughout the city, because there are fewer transportation available. So you know that okay, rain has a impact with my commute time, so I'll start a little early. Similarly, the machine tries to learn, okay, there is rain, the time is going to longer, so it will try to predict that okay, the commit time is going to high, but the machine can done it in a much more efficient and precise way. So that's why machine learning is used. And artificial intelligence is like any programs with the ability to learn and reason like humans. So the artificial intelligence that we have are not exactly artificial intelligence, it's just like try to mimic human behavior. So if you think some example that uh, think about autonomous car, it's learning from it's acting like a human, right? It's you are not driving the car, but it's assessing the road condition, it assessing the other cars, it assessing the road signs and everything, and it's trying to make a decision like human. So that's like artificial intelligence. Let's move on to the next slide. This is just like a workflow. So there are just for the sake of it two different types of workflows. One I have shared here. One is business analytics, and another one is data science. More or less, the process is similar, but there are some slight differences. So in the business analytics, the process usually starts from discover a business need. So when there is a problem that business has realized, that's like when they know that okay, we have a problem, or even if you don't have a problem, we want to improve this area of the business. And then you try to define or understand what the business problem is, and then what may be the related data related to this problem, and then you move on to the next step, which is collecting data. So once you know the problem, again I'll go back to the customer churn model. So you know that the problem is customers, you have a declining customer base, and then you may go back, collect data for customers transaction, for customers purchase behavior, for customers demographic data. So you will collect only related data. When I say collect data, it means that these data are already available in your organization's database. You are just defining which tables to use for your analysis, because there will be lots of other data like accounting data, finance data, and maybe even other customer data which may not be related to your problem at hand. And the next step would be analyzing the data. Analyzing the data would be kind of just going and digging deeper, looking at the data, looking at different statistics like median, average, and trend and pattern uh, over time. And then after analyzing the data, you can try to build like some predictive models and try to predict the outcome. So this is kind of like a, here it's like a step forward. So sorry, it's taking a leap of a step. So once you analyze the data, you may go back to business and see okay, validate your identify validate your understanding or discovery with the process and see if it actually making sense. And then you may move to the next step, which is trying to predict the outcome, what's going to happen next. And based on those, you may try to find the best solution to mitigate the problem that you are having, and then make a decision. So this whole process, you can think about that customer churn process: identify data, analyze data, and predicting which customers are likely to churn in future. Find the best solution is what percentage of promotion to offer or which promotions to offer, and making the decision that okay, I am going to make this promotional offer to this 10% customers, and go on. And it's more like an iterative process. It's like you may solve one problem one, but you may see similar problem or like same problem happening again, but this time the reason may be something else. So this is like a loop. This is not like a straight line or the process ends somewhere. And in data science is also more or similar, but here you are like a little bit more streamlining the process. You are creating a process that runs its on its own. So you have like customer data, you run this through your process, and then it will always give you a prediction that okay, these customers are at high risk of leaving. So you can continuously provide offer to those customers, those particular subset of customers, not to all customers. It's more or less same. I'm just like showing it for because this there are two different practices in this for these two, you can say, name data science and business analytics. And what skills do you need to be a business analyst or data scientist, or what skills do you need to be successful in this domain? So data science or business analytics is more like an intersection of three different domain or three different subject area. One is computer science, one is math and statistics, and another one is uh, domain knowledge or business knowledge. So you need business knowledge, you need math and science, math and statistics skills, and you need some computer science skills. um, and there is nothing to be intimidated of if you belong to any particular group, or even if you don't belong to any group, because um, everything could be learned. So if you think about a computer, someone, a student from computer science, he may have advantage in this area, but he still needs to develop the other two skills. Whoever is coming from business, they have advantage of business knowledge or business processes, but they still have to develop the math and computer science skills. And this is you can learn with some effort. So for this, I have defined like or categorized the skills into two group. One is soft skills, which is as important as technical skills. You need to be curious. So when I say curious, you need to be able to challenge yourself or challenge the established norm. When we say okay, we have always known that this happened like this, so you may be able to, or you have to be able to, okay, is it the right statement? You need to be go back and validate that statement with data. You need to be able to think critically to how to look at data, how to divide those data, or how to analyze those data. You need to have problem solving skills, and interpersonal and communication skills, because almost always the end users or the use or user of the analysis or the data science product is going to be the business group, and they may not be as uh, they may not have a very well understanding of the data science and analytics process. So the you may have to be able to communicate those in a simple manner and convince them that okay, this is the solutions, because people want to stay in the status quo. So they have a notion that okay, what I have known so far is the best knowledge. But you have to be able to challenge that through your communication interpersonal skill and convince them that whatever you are seeing in the data and whatever the data is telling you is the uh, might be the answer. And in terms of technical skills, these ranges of skills will vary from the type of role that you'd be working on, but I have tried to list some. It may not be necessary to have all the skills, or you may be able to do this with even one tool. So in terms of like some sort of programming, you may want you may need Python and R programming skills. These are open source softwares for analyzing data or doing anything with data. And another one is SQL, structured query language. So SQL is used to derive information or like take information from the data bases. So in organization, the data is stored in databases, and then you want to get those data, you have to use a structured query language so that you can retrieve those data or collect those data. And if you go like a little bit more advanced level, then you may need some cloud computing knowledge or skills. AWS is from Amazon. It's Amazon Web Services, and Azure is from Microsoft. So these are cloud computing. So cloud computing is more like, you can think of everything or all the applications are moving towards cloud, and the reason, there is a good reason for that, and that's like give you very much lots of flexibility. So think about, you are not sure how much data you're going to store in next month, so you may have to buy storage, you may have to build up a server. But with cloud computing, you can get those resources as you need, and you can shut down resources if you don't need. So it's more like lot of cost savings, and you don't have to spend lots of time managing servers, managing resources. And when you are deploying a solution, a data science solution, it's usually done in the AWS or using Azure, but that's a little bit more on the advanced level. You may still can do this, or do all this work in your personal computer as well. And you will need some visualization skills. Some of the tools used are on Tableau and Power BI. Power BI again is developed by Microsoft. And visualization you can done using even Python as well, or R as well, using programming language, but these are a little bit easier to navigate. And advanced Excel skill, I mentioned, because you can do almost everything with Excel as well. If you know Visual Basic, you can create the programs or write code. uh, or even if you don't know Visual Basic, you can do almost everything, create a chart or analyze data using Excel. It may not be very efficient, but you may would still be able to do that. And it may require a little bit manual process, which is like following different steps, and may not be very reproducible, but it's still doable. If you have Visual Basic skill, it will be reproducible as well. When I say reproducible, it means that you can perform the similar analysis on a new set of data, which is not used in this one. And you will need some knowledge of statistics. If you are using particularly data science, you may need a little bit more advanced statistics. But if you are using just descriptive and uh, diagnostic analytics, then you may be able to uh, it may be enough if you have like some basic statistics, like knowing uh, mode, median, average, how to look at data in terms of like percentage, what's the different quantiles. So those are a little bit more at the basic statistics level. um Next, let's move on to some examples. uh, so here I'm saying, giving example of uh, applications of data science. Here you can interpret it as applications of business analytics as well. And the first one is descriptive analytics. So this thing is just like a screenshot from internet I took. This is a dashboard. So dashboard is very widely used in business, and it's used for kind of like a status update. So you have the organizational database where you are collecting data, and you do some processing or some transformation to that data, and there is dashboard which is built on top of data. And some of these dashboards update maybe daily, some of these updates quickly, and some of these even updates real time. As soon as the instance or event is happening, these dashboards are updated. So that will depend on and no uh, no I mean, if you need to know that event as it's happening. And here you can see it's just like a sales dashboard. So you can see like during a particular time period, the sales is 1000 million or 1 billion, revenue is 1 billion. you have acquired new customers and gross profit is this much, customer satisfaction is this much, and you see where these customers are coming from. And you are seeing, okay, in London, customers are 2000, there are 2000 customers, and they are generating 865,000 revenue in revenue. And similarly in other cities, what's happening and who is the manager. And so this is just like, if you think about, you are a sales director or even a sales manager at some organization, you may want to see, okay, what's happening maybe on a day-to-day basis or on a month-to-month basis. So you can change the timeline on these dashboards to see, okay, what's the answer if I see last month, what's the answer if I see over last year, or what's the answer if I see at this over the last week or last day, right? So based on that, you may be able to see or identify issues that's happening almost near real time and take actions on those insights. Um, so as I mentioned before, I did a similar uh, webinar with a group of university students, and in that, before doing the webinar, I used a form to collect some information, and as a illustration purpose, I used that data to do some just quick visualization on that. Among the webinar attendees, 35% were female and 65% were male. And I see most of them, almost 35%, are fourth year students, and there are few master's students. So if I am conducting this type of webinar, if I collect this information beforehand, it's giving me the information that, okay, my most of my attendees are fourth year undergraduate students. So I may want to uh, create my presentation targeting towards them. Another information may be, okay, there are very few master's students. I may reach out to more master's students so that they are also benefited from this. And I also did some by education major, and most of the students were from finance. There were fewer accounting, very few pharmacy. So this also gives me some information that, okay, most students are finance. That's why you may have seen like some examples in the finance or in customer analytics, which is related to marketing. And this is again like how many signups, the number of signups by each hour of the day. And I see there was a huge spike at 10 in the morning. uh, think of this as you are a store manager and you have incoming traffic which increases at 10. So you may try to get some more employees from other areas and provide them at the shop floor to store, to assist with the customer. And you see, okay, at the later time there are fewer customers, so you can assign those uh, employees to some other was that they also need to finish. And this is just same like slicing that, our how many attendees signed up at different hours by education major. So I wanted to see, okay, what caused the huge spike at 10 in the morning. Then I sliced it down by education major, and I see, okay, the finance major students signed up mainly during that. So maybe some of the faculties may have mentioned in their class that, um, I reckon that's Sharif who mentioned that. But yeah, some of this faculty may have mentioned, and they may have signed up on the spot. And another application would be, so this is the next one is, so now I'm moving towards a little bit more on the predictive analytics area. And this is a example of time series forecasting. This is one of the, you can say, earliest application of predictive models, time series forecasting. And this is still important and is still relevant. So here the example of forecasting material prices. So here you can see how the price is moving and where the price is, and you are predicting what will happen in the next several months. So you are in, so we are in for here according to the chart on January 2020. So this is where we exist, and we want to know what the price would be in the next several months. So we are trying to predict what the price is going to be. So this helps to make important business decisions that, okay, if the material price is going to increase, I need to source more materials right now. It will also increase my price of the product, so on. So you can make lots of important business decisions if you know what's going to happen in future beforehand. And another example would be if you are in a working in a if you are a manager of a call center, you have incoming calls. So if you can know beforehand that, okay, for the next day I am predicting the number of incoming calls will be increasing, so you can probably get more employees at your call center to handle the more heavier load. And if you predict that there are going to be fewer calls, then you can probably employ fewer employees for the next several weeks or several days. Another application would be, so this is I am giving application and also trying to use different type of predictive models. So the first one I used was a forecasting model, and the next one is regression models. Regression is just used for whenever you are trying to predict a value, any numeric value, any continuous value you're trying to predict is going to be a regression problem. Some of the examples would be predicting ice cream sales given temperature. So you may see, or people have seen in the past, that the temperature or average temperature, daily average temperature has highly impact on how much ice cream you are going to sell. So you are in ice cream production and you know, okay, the temperature for the next week, and you see that, okay, the temperature is increasing. So you also want to identify how much ice cream you are going to sell, and there is a mathematical relationship between the temperature and number of ice cream units sold. So you would be able to derive that number, how much ice cream you are going to sell, using this process. You would probably never be able to predict with 100% accuracy. There would always be some error, because what happens in reality is different than what you are predicting. But you should be able to, with a good approach, you should be able to get quite pretty close. Another one would be forecasting sales with different scenarios. So you are planning or budgeting sales for the next quarter, and you want to identify an optimal setup for your sales team. So and your marketing budget as well. So you may try to plug in different numbers, like how many salespeople uh, to use, how much to use in advertisement expense, and how much to use in advertising campaign, uh, or how many campaigns, advertising campaigns to use. All of these will have an impact on sales. So you may want to identify uh, and use different scenarios. And how would you get actually, or how do you use this? It's like based on past examples. So you have data for like last 10 years, and you have examples that, okay, if I use 50 salespeople, if I have spent $20,000 on average in each advertising campaign, and I have used 100, not 100, maybe 10 campaigns in one quarter, I usually end up in $100 million worth of sales. And you have similar other examples. So based on those, you are creating a mathematical formula, and using that formula, you can plug in play different values to identify your expected number or expected volume of sales. Another one is classification. So here you are trying to classify or predict an outcome, whether it's going to happen or not. So here the decision is not a number, unlike regression where you are predicting um, how much you are going to sales how many ice cream unit you are going to sell, or how much total revenue or forecast, total sales you are going to make. In classification, you are trying to predict yes or no type of outcome. So if you are a call center manager, you would probably make some calls to customers where you would be promoting your product or trying to sell your product, or giving them promotional offer or trying to upsell. And they will have a decision. Okay, some customers will accept the product offer, and most of the customers may not accept the offer. Again, you have past historical data from previous promotional offers, and you can analyze those data and apply those data to existing customers to see which customers are more likely to accept the offer, and you will call them instead of just like taking a random sample of your customer and calling them. This will significantly increase the promotional offer acceptance, because you are sending offer to the customers that more likely to accept your offer. And similarly, it could be used that, okay, if I approve loan to this customer, is he going to default or not? So I would like to extend loan offers to customers who are less likely to be default on loan. The next one is, there are several. So one is clustering. So here I am trying to so this is just like clustering or creating different segments of customers. This is uh, an automated or unsupervised, unsupervised process. But here what I'm trying to do is, based on similar behavior, I'm trying to group customers into different clusters. So I can say one customer cluster where customers want the product immediately, where customers purchase in a small quantity, but in large volumes. In another cluster where I have customers who buys a small quantity but buys more frequently. So these are different types of behaviors, and there would be lots of other behaviors. I want to identify all those behaviors of customers so that I can devise appropriate marketing or financial planning for this group of customers. So if I see one segment is a little less profitable, I may use less resources on that segment. I may even let them go because they are less profitable or not profitable for me. On the other hand, if I find some segment which are more profitable, I may want to keep those segment, or I may want to uh, target some promotional or marketing campaign towards the less profitable segment, so that they are making more purchases. So it will depend on your business need and what business outcome you're trying to achieve. But that's there. There is another example of survival analysis. So this is just like used in my use cases, in my role. Like, it's predicting when a machine is going to fail, or how long it's going to stay well until it fails. And it's actually used started being used in the medical science first, where the analysis or a study included how long a patient is going to survive after going through a particular study, a particular medical procedure. So they wanted to know or study the impact of different procedures, or like what's the survival rate of different procedures. And that's kind of later being replicated in the maintenance or predictive maintenance. And anomaly detection is there. So anomaly detection, you are trying to is used for fraud detection. So if you think about credit card transactions, there are millions of transactions happening every day, but some of those are fraudulent. Maybe card informations were stolen, or someone may have gotten the information, or just like came up randomly with the card number and everything, and using that to make purchases. So these systems automatically detects those fraudulent activities and stop those. And again, identifying like anomaly in manufacturing equipment. So if you can identify that, okay, this equipment is not operating normally, or this is in anomalous state, you may take action to fix and see what's going on. Another one is recommendation system or recommendation engine. This is if you use Netflix, you see suggestions of other shows or documentaries or movies based on what you have seen, and it will vary from person to person. So it's using a recommendation engine to recommend new shows. Similarly, if you use any online shopping site like Amazon, they would be suggesting products based on what you have purchased, or based also on what other people have who have purchased. Say for example, you are buying coffee maker, so it will suggest that okay, people who have purchased coffee machine, they have also purchased some coffee mate or some ground coffee. So they are suggesting behavior or products based on frequently purchased products together, or what you might purchase. uh, and last but not least is natural language processing. So natural language processing is the example of analyzing text. So if you remember the example from the customer reviews on Google, you can probably do a sentiment analysis on each review, or on the aggregation of the review, and analyze uh, what's the sentiment of the customers. And if you see most customers are giving you a negative review, that's a flag, and that may require you to take some actions. And it's also used in translation and used in document summarization. And other than these, there are some other examples that are used in image recognition, but those are a little bit more an advanced level, and I have not included that. So I think that's all I had. So, uh, is there any questions or?
Thank you, Mr. Imran Salim. That was a very insightful and innovative and informative session. We have a couple of questions actually. We have a lot of participants who have typed in their questions. If you can, I hope, shall I be saying them to you because
Yeah,
they're
I
here?
can see the questions. So I will read out loud the question so that I can read, and also the audience knows which question I'm answering. So question is the job of business analyst and data scientist same? Are analytically challenged companies less profitable in their respective market segments? So I'll go one by one. So is the job of business analyst and data scientist same? So the answer is it varies depending on company to company, but most likely, or in most organizations, there are some differences in business analyst and data scientist job. Business analyst jobs usually include building doing some analysis on um, data, building some sort of dashboards, and doing some diagnostic and predictive analytics. And data science is used a little bit more on a broader term, so where data scientists do all those previous work of a business analyst, and also does some predictive analytics work as well. So there would be some variation, and the requirement for business analyst and data science may vary. The next question is: are analytically challenged companies less profitable in their respective market segments? So this is a little difficult to answer. I think it's a very good question, but uh, I am not aware of any such research where research being done where less analytically savvy company being less profitable. Uh, yeah, but I think that's a good question, but I'll probably go back and look into that. What's the answer? But in general, it may tell you that okay, you may be able to make better decisions using data, using what has happened, rather than using your gut feeling that okay, this is what I'm going to do. And you would see like almost all companies to some extent, almost all successful companies to some extent would use this type of techniques. I don't think you may be able to go very far if some of your competitors are using analytics and you are not using. But if the industry trend is that no one is using any advanced analytics or any analytics, then it may be all the companies would be at same, but some companies may get some edge if they are using analytics to improve and make their decisions.
Mr. Imran Salim, I have typed all the questions actually. You can actually, if you have a time constraint, you can select some of them and kind of answer.
Oh, okay, okay, yeah, sure, sure. Um, uh, so one mention, please mention which software you used for this analysis. So I used mainly Python to create those visualizations and even to create that chart, create that text cloud that I shared at the beginning. So all of these are done in Python. And I may have used, I don't remember, I may have used Tableau for some of these. Yeah, so I have, so some of these are created in Python and some of these are also in Tableau. So someone asked, I'm looking forward to work in business analytics field in future. If I want to conduct a research, which field of business analytics will you recommend? So that will actually depend on lots of other factors. For example, which okay, let me think about that for a moment. Actually, this is difficult to answer without knowing a little bit more about your uh, skills and knowledge. If you think you are very good at mathematics and statistics, you can probably do some research in deep learning or deep neural network. Or if you think that okay, you just want to do some you don't have that strong math and statistics background or computer science background, then you can probably try more into descriptive type of analytics. So it will actually depend on what the prospect in your location and what's the industry practice. So i- if you get back with some specific I may be able to answer that question. Oh, yeah, I think this is a good one. How much of the solution to an analytical talent gap comes from formal training via master's, PhD, or MBA degrees? So I would say like all my analytical knowledge and skills I develop almost all during like very small portion of my work after my undergraduation, but most of those were acquired during my uh, master's degree. And the reason for that is you would get familiar with the concepts and knowledges and techniques and tools during your formal education, but most of the learning is hands on, so you will be getting that skills when you are working full time after your graduation. So you may still do some work in your masters, you may do some project, you may have some homework, but those are kind of like more like a defined problem or setup problem, or the professor knows that okay, if I apply this solution to this problem, it will generate these results. But in business it's more like an experimentation, so you have to acquire that skills when you are working. And some other questions include what is the difference between business analytics and market survey? So business analytics, market survey could be a subset of business analytics. Business analytics is as a whole group um, which would include analyzing any data, collection of any data, and making decisions. And market survey is just particular subset where you are conducting a survey on your market to understand the market behavior and market characteristics. And some of these even could be available in your database from the past transaction data or from some other data that you have in your organizational database. So market survey is just like a segment or subset of business analytics. Yeah, is there any other
I think we have fairly answered a lot of questions. If there are any other questions, I would request the participants to probably quickly type in, or we are ready to wrap up. Any last words, Mr. Imran Salim, for our participants? We would be hoping to see you again with yet another webinar, hopefully.
Yeah, sure. I think I'd say if you are interested, it's fairly easy to get in. There are lots of online resources, online courses by Coursera or Udemy, so you can probably go ahead and get started with business analytics. And some of the tools that I mentioned, some of these are proprietary, like Tableau, Power BI. You need a license, but the open source ones like Python or R, those are open source, so you can download those on your machines. And there are lots of resources and lots of courses, so you can probably go ahead and get started. And you will even find like examples of how people have used. So you need to be able to just like go into the internet and search and look for some examples, and you can probably go ahead and get started.
I think we have one last question. That is, what institutions can you recommend to someone running for a business analysis training? I think he's asking for different courses or programs which will help a person develop their skills on business analytics.
Yeah, so I think it may refer to online institutions. So I think I was answering that, okay, Udemy and Coursera are two most widely used, so you can probably use this. And there is another one which is called Data Camp. That's very specific to particular segments. So if you want to learn Python, R, and SQL, that's a good resource. That website is a good resource, but it's you have to buy subscription. But I have seen what usually they do is, if your professor from your program opens an account for the whole class, they usually make it free. But for that, the professor of the course has to contact them, and I don't know how actually that works, because I had that during my masters. But other than that, you have to purchase a subscription. But other than that, Coursera and Udemy are great resources for that.
Thank you so much, Mr. Irman Salim. One another participant has requested for another question. That is, I think he has studied business all his life, probably all his undergrad and university, I guess. Now, if he wants to become a data analytics expert or a data scientist, is it possible for him?
Yeah, so so was mine. I also studied my undergrad in business and worked in more mainly business role. And then I started my MBA, which was also business, but then I transitioned to business analytics. So it's definitely possible if you have that mindset to learn and grow, to learn new things, which may be outside of your comfort zone. So you have to put some effort. So it's definitely possible to become a person in business analytics. You can do self-learn, you can go through some formal education, but it's definitely possible. And I have seen some of my former colleagues are also getting into data science. They have gotten some opportunities. So when I say former colleagues in the role that I worked after my undergrad, and they are also from business background, and they are also doing some different online courses and getting into business analytics and data science.
So yes, Mr. Imran Salim is a direct example of how a business, for person from a business background can become a data scientist in future. All you need is the correct guideline, I guess, and the correct focus of learning the new things. That's all from our end, actually. We would really like to thank our participants for joining us from across the world. We have participants from Malaysia, Bangladesh, India, Pakistan, and many other countries across the world. And Mr. Imran Salim for joining this webinar and for sharing such insightful information with all of us. I would request all our participants to please put their attendance in. We have shared a link for attendance. You'll be given certificates, and that's all from our end.
Yeah, and I'd
Mr.
like to
Mansalim,
yeah, I'd like to take a
yes.
moment to thank you, Aminul sir, and also to you, Bondi madam, for organizing these sessions. And thank you, Aminul sir, for hosting this session and giving me an opportunity to share my thoughts and ideas in business analytics.